In this video, you'll learn how to create components in the context of an assembly, insert components into an assembly, create an assembly joint and set the joint's motion, insert common hardware components via McMaster-Carr, create contact sets, set a joint's limits, define a rotational or translational relationship between components. I'd like to start by introducing a few of these topics. To create a new component in the context of an assembly, go to the Assemble menu and click on New Component. In the dialog box, you can set if that component will be internal or external. An internal file is stored in the assembly file. An external component is saved as a standalone file that is inserted or referenced into an assembly. After creating these components, they will appear in the browser. You know you're working in assembly when 3 cubes are shown at the top of the browser. When you're working on a component file that is internal, it'll be represented as a single cube. If the component is inserted or referenced into an assembly, it'll be represented with a cube and a link symbol to the right of that cube. Beyond components, you can also create subassemblies that are either internal or inserted into an assembly. These will also be represented with 3 cubes. Next, I want to talk about assembly joints. Assembly joints are different than assembly constraints. Joints allow movement and can only be applied to components. You can also prevent a joint from moving. Inside of Fusion 360, we refer to this as a rigid joint. We have 2 different types of joints inside of Fusion 360. The first is an as-built joint. As-built joints are used to define a relationship between 2 components that are already in the correct location. Next is an assembly joint. An assembly joint also creates a relationship between 2 components, but with this tool, the first component selected will move to the second selected component. If you need to edit an assembly joint, you can do that in the browser or in the canvas. Next, I want to introduce McMaster-Carr. McMaster-Carr is a company that supplies hardware, tools, and raw materials to industry. In Fusion 360, we link directly to their website and insert common hardware components like nuts and bolts into the active assembly. Next, let's look at some of these items inside of Fusion 360. Note at the top of the browser, the 3 cubes representing that I'm already working in an assembly. And you can see that I previously created this bracket component in the context of the assembly, again, represented with a single cube. First off, if I click and drag on that bracket, you can see that it can move freely. First thing I want to do is prevent the bracket from moving. To prevent a component from moving, I have 2 options. First off, in the browser, I can right-click on a component and select ground. If I do that, that component will no longer move. However, if this would become a subassembly in another assembly and it would move, the origin would not stay with this subassembly. The origin would stay at 0, 0, 0. The preferred method to do this inside of Fusion 360 is to create an as-built joint. From the Assemble menu, I'm going to click on As-Built Joint. Then I'm going to select the bracket and the top level name of the file. And in the dialog box, note that the joint type is set to rigid, meaning that it won't move. So if I go ahead and click OK, if I try to click and drag on that bracket, it will not move. If this assembly now is inserted into another assembly and it moves, the origin will move with the assembly. Now I'm going to turn off the visibility of the origin. The next thing I want to do is create a pin in the context of the assembly. To do that, I'm going to come up under the Assemble menu and click on New Component. And in the dialog box, I'm going to change the name to Pin. So you'll notice a couple things happened. The bracket got grayed out because it is not the active component. And in a browser, the component pin has been created and it is active. Currently in the timeline, there are no features because we haven't modeled anything yet. Let's quickly model up this pin. The first thing I'm going to do is create a sketch on this front planar face of the bracket. Going to click on the circle tool, located at its center point, give it a diameter of 0.5. Finish the sketch. Then I'm going to extrude that circle back in -2.25. Then I'm going to create a second sketch on this front planar face of the pin, create another circle that'll be concentric with a diameter of 0.75. Again, I'm going to start the extrude tool. Notice inside of Fusion 360 is that you can select individual profiles. So you can see what happens when I first select that outside profile. Then when I add the second profile, I can give it a dimension. For reference, if you make a mistake and you want to remove your profiles, simply click on the X in the dialog box, and then you can reselect your profiles. Here I'm going to click OK. The last feature I want to create is a chamfer. So I'm going to go under the Modify menu, Chamfer, and I'm going to select this outside edge, give it a distance, go ahead, click OK. So there's my pin. Then I'm going to make the top level assembly active. Now, if I click and drag on that pin, you'll notice that I can freely move that. I'm going to revert it back to its original position. Now what I want to do is create a relationship between the pin and the bracket. Since the pin was modeled in the correct location, I can use an as-built joint again. So again, from the Assemble menu, click As-Built Joint, and I'm going to select the pin and now the bracket. Because the pin will rotate, I'm going to change the joint type to Revolute. Then I'm going to select the origin for the Revolute joint. I'm going to select on the inside circular edge and go ahead and click OK. So I know it's hard to see, but if I click and drag on the pin, it can rotate. Next, I want to insert the clevis into this assembly. I'm going to display the data panel. In the data panel, you can see that I already have the clevis modeled up. And this is just a single component file. To insert this clevis into the assembly, I can right-click and click on Insert into Current Design, or if you have a Windows computer, you can also click and drag that component into the canvas. To make it easier to see, I'm going to drag the clevis out of the bracket. Go ahead, click OK. Now I no longer need to see the data panel, so I'm going to close that. Before positioning the clevis, I'm going to turn off the visibility of the pin. As you can see, the clevis is not in the correct location. So I'm going to use the Joint tool found under the Assemble menu. And I'm going to zoom up tight with the Joint tool. As you move your cursor, it will pick up points. Now the point that I want is going to be the midpoint of the cylindrical face. As I move my cursor, it's picking up points on different faces. So I'm going to move my cursor back over that cylindrical face, hold down the Control key, and it filters out all of the other faces. So now I can easily select on that midpoint. So next, I'm just going to zoom back here a little bit. The next point that I want to select is going to be in between these two ears. However, there is no geometry there for me to pick. Instead of creating planes and axes inside of Fusion 360, we make this really easy. In the Joint dialog box, I'm going to select between two faces. Then I'm going to select the inside planar face, rotate my viewpoint, select on that second inside planar face, then select a circular edge. And that gives me my center point. Now that the clevis is in the correct location, I can select on the Motion tab, and here you can select on different motion types. So for example, we have the Revolute, we have Slider, which will go back and forth. Cylindrical will go back and forth and rotate. Next, we have Pin Slot. Think like a bolt within a slot. Then the next one is Planar. You can slide within that plane. And then the last one is a ball joint, rotating 360 degrees. From these motion types, the Revolute is going to be the one that I want here. Go ahead, click OK. Next, what I want to do is insert a socket head cap screw into this assembly. I'm going to do that by going under the Insert menu, Insert McMaster-Carr component. And as I mentioned in the introduction, we're linking out to their site. So here you can search for a specific component, or you can make your selections through the dialog box. Here, I'm going to pick on screws and bolts, then socket head screws, and socket head screws again. For the measurement, I'm going to select inch, then define the thread size, and then the length, then select the material, and then the finish. Once you get to the point that you could order this component from McMaster-Carr, you'll see a part number displayed here. Then below here, you see product detail CAD. In the drop-down list, make sure that this says 3D step, and then click download. The component will be created in the assembly. Here, I'm going to click and drag and move it out, and then start the joint tool again. Now I'm going to pick on the inside circular edge, and that will pick on the center point. For the second selection, I can select on the face and then the center point. So it doesn't matter. You get the exact same thing. Now you'll notice that the bolt is pointing in the wrong direction. I can fix that by clicking on the flip option in the dialog box and then click OK. Next, I want to pattern the socket head cap screw so it goes into the remaining holes. To do that, I'm going to start the rectangle pattern tool from the Create menu. In the dialog box, ensure that Components is selected for the type. For the object, I'm going to select the bolt. In the direction area in the dialog box, I'll click on Select And to set the direction for the pattern, I'll select on the two edges on the bracket. To complete the pattern, I can either click and drag on one of the arrows and adjust the values as needed, or you can do this in the dialog box. So here I'm going to change the quantity to 2 and the distance to 1.5. Next, let's look at motion, and to make it easier to see, I'm going to click on the front plane on the view cube. Now, if I click and drag on the clevis, you can see that it can go right through the bracket. Of course, we don't want that, so I'm going to revert it back to its original position. There are two different ways to solve this problem. The first is creating a contact set. To do so, go under the Assemble menu, and the first thing we're going to do is enable contact sets. Then under the Assemble menu, click on New Contact Set, and then pick the clevis and the bracket. Go ahead and click OK. Now when I click and drag on the clevis, you'll see that it stops on contact on the bracket. Even though this method works, it's not ideal. As you're dragging components, the computer has to do a lot of processing. The method I prefer is to set joint limits. First off, I'm going to delete the contact set. I'm going to go in the browser and right-click on Contact Set and delete it. There's two ways to edit a joint or joint limits. The first is through the browser. If I expand the Joints folder, you'll notice that my joints are displayed here. To edit a joint, right-click, and from the menu, either click Edit Joint or Edit Joint Limits. The second method is to edit the joint via the canvas. To do this, I'm going to turn on the visibility of the joints. Then I'm going to switch back to my home view. To edit a joint, move your cursor over the desired symbol and right-click. And from the menu, either click on Edit Joint, or in this case, Edit Joint Limits. In the dialog box, I'm going to check the minimum option and enter the smaller angle here. I'm going to do -60 for the minimum, and in the maximum area, I'm going to set this to 90 degrees. Go ahead, click OK. And again, I'm going to change my viewpoint to look at it from the front view. Now, when I click and drag on the clevis, you'll see that it stops at 90 degrees and -60. This is a preferred method because the joint is being controlled mathematically. The last topic I'm going to talk about is how to create a rotational or translational relationship between two components. Now I'm going to make my gears file active. To make it easier to see, I'm going to change my perspective to the top view. In this file, I already created two revolute joints. To see that, I'm going to expand the joints folder in the browser, and here you can see my two revolute joints. Now, if I click and drag on these gears, you can see that they move independently. What I want to do is create a rotational relationship between these two gears. To start, I'm going to revert the gears back to their original position by clicking on Revert. To create this relationship, I'm going to go under the Assemble menu and click on Motion Link. In the browser, I'm going to select my two joints. In the canvas, you can see the preview. And in the dialog box, you can see that each of these are set to 360 degrees. To start off with, I'm going to click OK. Now, when I click and drag on the gears, you'll notice that they do move together. However, they are not aligned. To fix this, I'm going to edit the motion link. Again, before doing that, I'm going to revert them to their original positions. And in the browser, I'm going to right-click on Motion Link and click Edit Feature. In the dialog box, I'm going to change the angle for the larger gear to 180 degrees and leave the second at 360 degrees, meaning that the first gear will go 180 degrees while the smaller gear goes 360. Now when I click and drag on the gears, they align perfectly. To show how joints and Motion Link work together, you can also right-click on one of the joints, and from the menu, click on Animate Model, and all the joints in the assembly will simulate. When done, press the Escape key. Here I opened a file that I added a track component to the gears. Another use for Motion Link is to set up translational movement. I also created a slider joint that allows movement along a single axis. Then I added a Motion Link, which I set between the revolute joint on the larger gear and the slider joint. And here in the dialog box, you can see that I set the angle to 15 degrees and the distance to 1.389 inches. So what that means, as the larger gear rotates 15 degrees, the track will move 1.389 inches. By creating two motion links, you can see no matter which component I move or rotate, the other two components move or rotate. This completes this video on the assembly modeling process inside of Fusion 360. Thanks for watching.